Hello, everyone, and welcome. It is Wednesday, the 6th of April. It is time again. Well, it's the Gretzky Show. It's our 99th weekly episode in a row. So, Gretzky Show. We are here for the Knowledge Bolide Weekly Hangout, sponsored by Topher Spin Meteorites. And this is the show we've been waiting for a long time. We got Lunar in the house. Going to talk about everything lunar related. And I'm interested because I'm always constantly learning myself. I want to learn and I sent Mike a message. I want to learn a little bit about gabbro, feldspar, felspathic, fragmental. I want to learn what all these terms are. So if we stick around, we're going to see some amazing lunar samples and learn a lot about it. The first thing we're going to jump into is some video. We have different ends of the spectrum here. We have a video from Damian in Croatia, a VIP member of our crew, and he is showing you that you can get your bang for the buck on the moon if you stay small and use the right lens. So he's going to show us how to make macros look amazing. Then we're going to jump on the other side of the spectrum. We have a video from Mark Lyon, a very serious collector dealer, and he is lunatic on a kick right now. So he's going to show you some of the biggest lunar samples of the day. We're going to get those out of the way, and then we're going to get into our samples. Okay, so as promised, we have this lunatic and I'm copying him because he's the one who says in his video, and it made me crack up. So this is Damian in Croatia with his macro work.
Hello, fellow lunatics, and welcome to my tiny lunar collection. 3 years ago, I don't think I could have had a better start of my collection. This slice of the legendary lunar has both metal blobs and tiny, nice vesicles. Got it at the time for the incredibly low $40. It's still the main star of my lunar collection.
Audio is choppy.
Next is extremely thin slice with fantastic surface area of a widely available NWA 11273. It's a beautiful breccia with large variety among its clasts. Even with the slice no thicker than 1 mm, both sides look quite different. Tisserlitine 001 is one of those unique lunars, being the only one that's been hydrothermally altered. It's got unusual wavy and flowy structure. It also contains small amounts of spinel troctolite, which is the deepest lunar crust material we have. Even with just 10 milligrams, this golden lunar micro still shows its beautiful brecciated structure.
Wow.
Next is another very fine feldspathic breccia with a somewhat unique look. This is also my only lunar end cut, showing beautifully contrasting desert varnished exterior.
Very cool.
This much rarer fragmental breccia classification is by far my largest lunar. It's still one of the nicest dark lunars I have seen, with very fractal structure. A very detailed Medbull write-up by Carl G recognizes incredibly at least 9 different lithologies.
Wow.
Nice.
Currently my most exotic lunar material, a tiny fragment of a lunar troctolitic granular breccia. I even have a beautiful translucent green melt vein that this material is known for.
Jeez.
Lastly, my latest lunar that has arrived just today, and it's a cool one. Gadamis 003 is a ferroan anorthosite. Its unusually high anorthite content make it very similar to Apollo 16 moon rocks and different to most other lunar meteorites. I'm happy I was able to add this one to the video at the last minute. That's all I currently have. My collection may be tiny, but as I always say, with the right lens, even a micro can be quite large enough. For a tutorial on macro photography, tune in again in 2 weeks. See you then. Bye.
Right on. Thank you, big guy.
Yeah, that's a
Awesome.
wonderful video.
Very nice.
I'm glad that he showed a few of these. This is the NWA 5000, the legendary Lunar, and probably, you know, you can't afford it. It's expensive. It's like $300 a gram, something like that or more, but it's very, very beautiful. And I would say only second to this very available one here, 11273.
That's pretty.
Yeah, Chris Monk has a beautiful piece of this. He's going to show us later, this exact classification. There's a lot going on in these lunar samples. It's super interesting to me to think about this one here, Tisserlitine 001. He mentioned it was aqueous altered. It's the only one, and there's the science has proven that water did the changing, the altering on the moon, not here. These were water-bearing lunar rocks.
That's cool.
So thank you, Dom. Appreciate that. All right, so now we have our first video submission from my friend Mark Lyon.
Hello, this is Mark Lyon. I just wanted to show you a few of the lunars that I have. I'm really passionate about lunars because there's so many different varieties. You know, each lunar you get looks a little different. Starting here, this is kind of the standard breccia that, you know, one would expect from a lunar. You know, I really appreciate the ones with the really nice white clasts and the dark matrix. So these ones are pretty nice. Another one, which is the same class but looks completely different, is this lunar. This is the 13951 that I had classified, that we designated as being Starry
what a
Night,
flab.
because, you know, it sort of looked like the starry nighttime, that I thought was pretty cool. As other types of lunars go, I have this one. I can't remember the number on it right now, but it was classified as a troctolitic melt. It kind of takes a little more effort to appreciate its beauty, but it has a lot going on there.
A lot of
so
melted
you can
flow.
see the kind of waves of the melted area and many different clasts and stuff. So I think it's pretty nice. What else do I have? Oh, I've got this.
I got this laying around.
Really nice lunar gabbro piece, troctolitic gabbro, that I think is also pretty special. You know, this is kind of one of the rare lunars that I think is better not to cut and to just keep as its own unique piece.
That's the troctolitic lunar. These melt lines right here, these shock veins, that would be, if you cut it open, you'd see that translucent green glass inside. That's what it looks like on the exterior.
Is that what lunar crust looks like, or is that weathering?
I don't think that's crust.
Yeah, I don't think that's crust weathering. Lunars usually have somewhere between kind of a dark cream color and a milk chocolate brown sort of color. NWA 482 was famous for being one of the first ones with decent fusion crust, and it looks like melted milk chocolate.
Have is Gadamis 4.
Whoa!
This is a pharaonic anorthosite, and it's known, you know, if you look in the Met Bull, it's very similar to the Apollo 16 samples, so it's really cool for people who, you know, are interested in the lunar missions and things like that.
That is a crazy, huge piece of Gadamis.
It is, and I was offered that one, and there were a lot of zeros involved.
I can imagine.
Yeah.
God, Mark's hijacking the moon.
There's not a museum on the planet that you could walk into and see that many different lunar meteorites, period, end of discussion.
I'd like to show you my sample of that one. This is Gadamis 3. So this is 9.2 grams, and it is the ferroan anorthosite. So the very similar to the Apollo samples, as he said.
Wow.
That's
That's
That's awesome.
yeah.
And it
Knocked it right out of the park with that one.
Yeah. The structure of it is definitely different than any lunar I've looked at under my microscope.
Mm-hmm.
And this is kind of what some of the color of, this is not fusion crust, but that's kind of what the color of some of the fusion crust on lunar looks like. It's that yellowish marshmallow. But this is the stuff that matches the samples that we brought back pretty closely. So really, really interesting stuff.
Certainly is.
And Sue's going to mention Gadamis 004 later on tonight. Right now, we have show and tell with Jules. So we'll check in with her real quickly. All right, Jules, what are we looking at today?
This is 7 grams of feldspathic breccia, NWA number 13676. I found it in Tucson. I think his name is Michael Van Den Dries.
Van Den Dries.
Thank you.
He's from the Amsterdam.
He was very nice to deal with. He gave me a great deal on this. I was going to cut it, and I changed my mind. Not going to do it. And
we're gonna see a lot of slices today, so it's nice to see an exterior of a stone or a complete stone.
Yeah. And then, you guys had enough of that one?
I could look at it long. That's beautiful. I like that. If you flip it over nice. So we can see the reverse side for 1 second, I wanted to point one thing out. There you go. Thank you. You can see some of those holes and voids, and even on the bottom at 5 o'clock, you see three bundled in a row in a little triangle. Those are not voids and holes that were there when the meteorite was fresh. Those are softer materials that have weathered and eroded and sandblasted out and maybe loosened up and fallen out. But so those are natural to find them that way when they're very weathered, but that is due to a lack of material that's been weathered and terrestrialized out.
Get that one in there.
Oh, that looks like 11303.
Nope. It's NWA 11421. It's a lunar felspathic breccia. It's 1.165 grams.
Oh, that's nice.
Super colorful.
Pretty well.
Oh, yeah.
Orange here.
That's cool.
I like being able to see the inside and the outside. So
absolutely. I have a question about the bottom of it. You see the big white class at the bottom. Can you rotate it around so we can see if that's continued on the other side?
Yes.
Yeah, it is. You can see the outline of it.
Cool.
Wow, that's interesting. I like that.
Mm-hmm.
Yeah, and that's just a little over a gram, you say?
Yes. 1.165.
Yeah. So
hard to hold on to.
You don't need to drop your paycheck to open, to have a little piece of a lunar collection. So, that's one of the things about the Hangouts is we want to show, that affordable pieces can still be enjoyed. And it's not even under a microscope yet.
Yeah, I kind of got morphed by Mark Lyons, but it's just under a camera and you can still see it. So that's cool.
That is awesome.
Beautiful.
Thank you.
Thanks.
Yeah, we had to get Mark Lyons stuff out of the way early. Because there's not many people that can compete with that. I mean, he's the main mass holder to those things, so he's obviously going to have the largest slices available. Yeah, I hope that we'll get a reoccurring thing where Mark sends us videos and you watch. I'll keep working on them. The quality will get better and better. The samples may not get better, but oh my gosh, yeah. Chris Monk, are you in the building? Oh, I see your camera.
I am in the building. How's it going, everyone?
Oh, Chris.
We talked about this one a little bit earlier. So this is 11273. This is a 27.35 gram. And what's really cool about this one that I like a lot, it's a slice, but it's a really thick slice.
Wow.
So you can
That's a slab.
so you can get a good look at the clasps from the outside.
Wow.
And what they look like pre-cutting. But then you get that nice interior. And this one was only, I want to say it was about 3 kilograms, when the whole classification is about 3 kilograms. And this was one individual stone that has 2 other end cuts. And at one time, didn't you say, Topher, that you owned all 3 of these?
Yeah, I actually got all 3 of them because they formed the continent of Africa.
Oh, wow.
Which I thought was really cool.
So this one's lunar felspathic breccia.
And
So,
Chris, if you would, I don't mean to interrupt, but that white class that we're seeing on the top at 1 o'clock, can you rotate it so we can see that around? Look at that.
Oh, yeah.
Total 3D.
Yeah. Wow.
A very pure color.
11273 is one of the most beautiful felspathic breccias I know of. It really is. Wow. That's beautiful.
That's a nice chunk.
So this one I'm going to show in the case for a second because I have the classification there. So this is NWA 13992. This is a fragmental breccia, but it looks like a boot.
Yeah.
And it's got nice colors in there. Some of the clasps are a little bit darker. Kind of gets that caramel color.
It's weird. When I first started collecting meteorites and lunar meteorites, all I really would see and knew that would exist were like the white and black one that we just showed, the normal, if you want to call it vanilla felspathic breccia. When you get into these fragmental breccias, which is I think 1 of 17, you really start seeing some unusual kaleidoscopes of colors.
Yeah. And I don't know. I mean, obviously, some of the materials are different in there, and I think some of it is a product, maybe a little bit of weathering. Oops, I'm going to throw the boot. But this is just a real interesting one. It has a lot of character to it. The colors kind of make it pop and make it stand out a little bit. I have a couple of individuals of this one also, but they're tiny.
I know that shape appeals to you after being at your wedding in a cowboy hat. So,
yes, it was actually because there was other ones of this that I was looking at, but the boot and Matt Stream is who I got this from, and Matt had the boot written right on the listing, and I was like, you know what, I need that.
Nice.
So yeah, I competed hard in that auction.
Very awesome.
And then the last one that I want to show is the most rare. So Mark showed one that had melt in it. This is entirely melt. Almost entirely melt. So this is classified as lunar troctolitic melt rock. And you can see all of the vesicles if I...
Oh, yeah.
And it actually has a hole.
Oh, cool.
Right through it. One of the vesicles goes all the way through. This side is the unpolished side. It has a little bit of crust. It's not, it's thin. This one right here is like 3 grams. But just beautiful. This is still, and I checked this morning, this is still listed as 1 of 1.
Wow. Troctolitic melt rock.
And it's weird that it adds rock on the ends, but
yeah,
that's literally what it's classified. Troctolitic melt rock.
It's very. I've wondered that myself when I see stuff in the Met Boas, but it's always melt rock. Like there's an EH melt rock or something like that.
Yeah.
Very interesting. Those are some amazing pieces, Chris. Look at that. The trifecta.
Yeah.
And just right there, look at the 3 different stones. They literally look different.
Yeah, very different. And, then you put the Starry Night next to it, and it looks different. Like, I really support what Mark Lyon said when he said that there's just so many varieties. And, I mean, even if you just look at the Earth, right? I mean, there's thousands of different varieties of rocks out there. And then we have so many different varieties coming from a close relative of the Earth. It's just an opportunity to see just the variety that's out there and how many of the known classifications could possibly be from the same parent body that we just don't know yet.
Yeah. I'm super excited about the fragmental breccias because like if that one, like Damian said, has 9 different lithographies in it, that's like we talked about Black Beauty being a polymic breccia from Mars. So it had like 12 different stones mashed into it, which, saves money and time when you're studying that. I'd like to show you my troctolite that has a melt vein in it. Okay, so this is my NWA 8687. It's a lunar troctolite. And I'm wondering if you'll be able to see, see the...
Oh, yeah.
I wonder if I can do it even better. Hold on a second. There we go.
Yeah, wow. So translucent.
That's cool.
A lot of transparency.
Wow.
So that is glass now. Maybe I was wrong earlier when I said the one on Mark's, the black lines, the shock lines were glass, because here you see shock lines that aren't glass. So I might have been wrong, but you get the point.
No, I think you're correct, Topper. There's another troctolite that was available, and I might have been the first one on the market, and it shows very, very green veins in it that are shock features.
Awesome. And I definitely think some of them too. So it's the same shock feature with mostly the same minerals, but trace elements in it cause it to, some of it is almost beer bottle green, that green glass you can see. And then some of it comes in various colors, just depending on the trace elements.
That's awesome. Well, we're going to learn about some trace elements and learn about the differences and the minutia of what we're talking about, because we're talking about lunar samples, and we're talking about like this one sample had 9 different stones in it. We're talking about all these different fragmentals, breccia, feldspar, feldspathic, troctolitic, melt. There's a bunch of terms being thrown around. So we're actually going to take a step back a little bit and go into Meteorite 101, which is our reoccurring segment of education. And today we're going to have our good friend, Mike Kelly, take us through Lunar Meteorites 101.
One of the most common questions are, lunar meteorites. How do we know that they are from the moon? And Pilfer did talk about a lot of different things about the mineralogy and the ion composition and everything. We'll get into all that, but this slide's all about the features of lunar meteorites that help tell us that they're from the moon. And so there are some interesting things in there, although we usually say, there's not enough metal in lunar meteorites to be attracted to a magnet. There are little bits of impactors in there, and what's neat about that is, in an environment like the Earth where there's a lot of free oxygen, all that free iron would oxidize and all become iron oxide. So you would have rust or magnetite, whereas when you cut open lunar meteorites, a lot of them will still have tiny little bits of unoxidized free iron in them, which is one of the things that helps tell us that they're from the moon. In addition to, they do have trace amounts of troctolite in them, which is FeS, iron sulfide. And again, on Earth, where you have a lot of oxygen, all that iron sulfide would oxidize and make sulfuric acid and would break down, whereas on the moon, that doesn't happen. So it stays as troctolite, and you can really tell that there's not a lot of oxygen present, so it's a very reduced environment. One of the cool things, and I was just picking this up too, is there are these things called agglutinites inside of the lunar meteorites that are regolith, so that surface layer of breccia. And so we have micro meteorites that hit the Earth and can be collected, but our atmosphere slows them down to the point where when they hit, they don't really do anything. Whereas on the moon, since there really is no atmosphere there, they come blazing in and they hit the surface at full speed. And so what that does is it allows them to still have enough energy in there that when they impact, they actually melt together with the lunar surface material. So that regolith, and what they form is little tiny microscopic vesicle-filled glassy particles with little bits of mineral stuck to them. Wow. So the presence of those agglutinites are one of the things that we use to tell if not only could it be a lunar meteorite, but could it also be from the surface, and thus a regolith breccia.
Mike, do you know how far down those micro meteorites may penetrate?
So I don't have an exact number, but I'm going with it's got to be just millimeters to maybe a centimeter at the max.
Okay,
it's a very, very thin layer, but then you get larger things hitting it and then returning that material over, like we talked about with the Mars, with the breccias and breccias, like the Black Beauty. The same concept would happen there. So some of that material may get buried, and you might find it in a small part of a lunar meteorite that you don't find in other parts of it.
And that means at one time it was close to the surface, but maybe not.
Yes.
Gosh, thank you.
Exactly.
Thank you very much.
So it may be in part of a rock in one class of a breccia, but not in the rest of it, because that piece was up top and then it got buried and lithified.
Very cool.
So moving on down, the other thing that's interesting is there's cosmogenic radionucleotides. So anytime you're on a body with no atmosphere, you're exposed to high energy particles coming from the sun and also cosmic particles coming from outside of the solar system. And as they run into things like aluminum and manganese, they will change the atomic structure of those atoms that get hit to the point that they now change their formation. And that only occurs in a no atmosphere environment. That doesn't happen on the surface of the Earth because the atmosphere on Earth blocks all that out. So when you find a rock, they can look for those radionucleotides in there, and if they're present, that means it's obviously not from Earth. It's spent some time out in space, and it's spent some time out on another parent body. And the other thing they can do is they decay in a certain rate, just like all of the radionucleotides. So we can use them kind of as a clock to tell how long ago that exposure occurred and how long it's been terrestrialized based on how much is left.
Way cool.
So those are a really good clock for telling us how old some of these lunars are and how long we think they were pitched off the moon from. The other thing that's really interesting about the moon is, although you got a lot of minerals that are same as the minerals on Earth, there really is not much water on the moon, right? There is water on the poles. We have proof of that, and in some of the crater areas that stay shadowed. But in general, the moon is a really, really, really dry place compared to Earth. So though you get a lot of the same minerals on the moon that you do on Earth, what you'll get is those same minerals will lack hydroxyl placements inside the crystal structures. So hydroxyl is basically a mineral that needs to form in the presence of water and incorporate the water into the mineral structure. And those are things like we talk about in carbonaceous with the clays. Those type of clays all require moisture layers in the silicates. So there is no abundance of moisture on the moon, and thus there really are no clays in the minerals and lunar meteorites that we have. We also really don't have a whole bunch of oxygen going on up there, so same thing. You really don't get a lot of oxides as far as minerals go. And then finally, we got the lunar sample returns, right? So that was kind of the final proof. When we have something like Gadamis 03, which was shown. And it basically aligns with like a sample from Apollo 16 chemically. That's a sure sign there.
Yeah, that's pretty good evidence.
Yeah. Yep. So like Mark was saying, there's a lot of diversity in there. So there are like 15 lunar categories. They all say lunar, but then they all have a parentheses and they're kind of telling you what it is. Total, we have 529 lunars as of yesterday night in those 15 subtypes. And the breakdown of those subtypes is really kind of a combination of a description of what character the rock has. So again, like a breccia or a monomict, is the terms like that are telling you the structure of the rock. And then the things like anorthosite or feldspathic or troctolitic, they're telling you a bit about the composition of the rock. So the minerals that are in there, the major chemical constituent in there. So it's a blend of two terms: what it's made out of, and an overall characteristic description of how it's formed.
And even more so on the last one, it's a troctolitic melt rock. So it talks about both.
Yes, yeah, exactly. Some of them will tell you one or the other, depending on who classified it. Some will tell you both. So you did ask about a bunch of terms. So I kind of boiled down some of the major terms. I skipped some of the really oddball minor things like the 1-of-1 norite on the moon, because we're not running across those in our collections. So anorthosite, that means that it contains primarily anorthite, which is a feldspar mineral. This is particularly, feldspar can form with either potassium, sodium, or calcium as the first element in the mineral. And so an anorthite is pretty much pure. All of those molecules in there will all be calcium based. So there really isn't a lot of sodium on the moon. It's all primarily calcium feldspar. And that end member where it's all calcium is anorthosite. So again, that's very, very, very abundant on the moon, and it's not really all that common on the Earth. So the presence of anorthosite in there is a good sign that you're looking at a potential moon rock. One of the other common terms we throw around is lunar basalts. So basalts, just like basalt on Earth, is a extrusive igneous rock. So that means it came out of a volcano on the surface of the moon, just like basalt on Earth would come out of a volcano on the surface of the Earth, or it got really close, so within meters. So basically what it means is, since it's so close to the surface, it gets to cool really, really quickly, and it forms very tiny crystals. You would say, okay, well, how do I tell an Earth basalt from a moon basalt? So the moon is really high in titanium and also iron content as a whole. So the bulk chemistry of a mare basalt from the moon would be higher in those two elements. And the majority of basalts do come from the mare. So those are the big dark spots you see when you look up on the moon. And basically what happened is huge impacts happened on the moon, and they fractured the moon to the point where magma was able to bubble up into those exposed craters and flood them. So it's a really thin magma. It comes up to the surface and it just fills in the whole crater area and forms those big mares.
And Mike, you're saying volcanic activity and magma. So we're actually talking about it coming up from within the moon towards the surface, not just the impact or melting a pool of lava.
Yes, correct. So yeah, what you're describing, the latter would be like an impact melt rock, whereas these are true basalts. So they flooded up back when the moon was still volcanically, and magmatically active. Now it's dead and cold and not active.
Cool to keep in mind. Thank you.
Yeah, and then you also mentioned gabbros, and so a gabbro is kind of an intermediate rock. So we said that those basalts are very fine grained. A gabbro is more coarse grained. So it's a bit of that magma that didn't quite make it up all the way to the surface or even really close to it. It stayed a little deeper underground, and because of that, it had a longer time to cool. And so when you start forming crystals and you give them more time to cool, they allow more growth, larger growth. So composition-wise, the chemistry inside those rocks can be the exact same as the basalts, but the crystal size will be a little larger, and so they call them gabbros.
Cool.
So melt breccias, basically there was a heavy bombardment period on the moon between 4 billion to 3.8 billion years ago. And that caused a lot of the surface material to be remelted, like you were mentioning, inside these large craters. You get a big impact, a lot of heat, and you will get melt breccias where there's chunks of existing crustal material inside of a matrix that's really just either vitreous, glassy, or really fine-grained from that melt cooling, depending on how quick it cools. And what's really cool about this is most of the breccias we see from everywhere have very angular clasts in them. Melt breccias, you'll see kind of more rounded clasts. And again, you see a lot of the I found a rock and, is it a lunar breccia? Well, most of the breccias from Earth will have rounded clasts in them from water activity. The ones on the moon, really only those melt breccias are the ones with the rounded clasts in them. Everything else will be pretty angular. Looking at troctolite, which we saw a couple pieces of already. So a troctolite is basically an anorthite that also has a olivine component to it. So you got olivine and calcium-rich plagioclase mixed together. And these are cumulate rocks. So they formed inside of a magma chamber. They start to form. They're heavy. They form kind of first, and then they start to sink. And they sink kind of to the bottom of the chamber. So they usually have bigger crystals. And then you're seeing all that melt and everything else. So that's secondary, right? So it all solidified. And then obviously a big impact happened. And then it got shocked and thrown loose and came to the surface, where it then likely got hit again, in order to get knocked off the moon into an Earth-crossing orbit.
So all those shock features we're looking at are post-formation.
Yes, yeah, those are like impact-type formation stuff. And then we talked about fragmental breccias. So again, fragmental breccias, they are polymix. So there are a bunch of different types of clasts from different parts of the moon. Some of it may be mere basalt. Some of it might be, Highlands anorthosite, all mixed up and jumbled together. And again, that means it's been turned over many times in order to create, that amount of polymix, multiple rocks being stuck together. And so that means it's really from the lunar surface, right? That's a very shallow rock. And so they'll be divided into regolith fragmental breccias, very top surface. And again, those would have those agglomenites inside of them. Or if it's slightly deeper material and they don't have those glass spheres, then they are just labeled fragmental breccia.
Very cool. And that's my new favorite lunar right now is fragmental breccias.
Yeah, it's not a whole ton of them. And again, if you think about it, you're talking about the very surface of the moon, right? Mm-hmm. So it's not a huge, thickness of material that you have to get a rock from. We already talked about the classification a little bit, so it's kind of interesting, right? We say we have these anorthosites, and then we also have feldspathic breccias, but technically, right, anorthosite is one of the 3 N types of feldspar. So it's kind of like there's a duplicate there when you see those feldspathic breccias and anorthosite breccias. It's just a matter of kind of how pure the anorthosite is. So is there some other ions in there? And again, we talked about it, based on who's going to tell you what it is. Was it studied by a geochemist, or was it studied by a petrologist? They're going to throw out different terms based on what they're interested in within that rock. Are they interested in whether it has a lot of calcium in it and thus it's an anorthosite, or are they interested in how it's put together? It's a feldspathic breccia, so they care more about the rock shape and clasts and everything else to it. And then, you do get a lot of diversity even within the fragmental breccias. So, like, if they really boil it down, you have those regolith breccias, you have glassy breccias, you have granulitic breccias. So I'm sure under the microscope, when you start looking at the matrix of these things, there's all sorts of different ways that they break them down and classify them based on the matrix structure. Why are they important, right? We have a very small amount of material we brought back from the moon from 6 sample return missions, 842 pounds. And it came at a really, really high cost to bring all that weight back. And then we have the hot desert and Antarctic lunar meteorites that come to us at comparatively speaking, a very low cost. And they give us more samples from different parts of the moon that we don't necessarily have a rock that matches from the lunar return samples. So we have more variety of the moon from the meteorites that we've collected to tell us, about the structure of the moon, its formation, its age, things like that, than we actually got from the lunar return samples.
And one other thing, if I could jump in real quick, Mike.
Yeah.
5 of your photos on the left there are, the Apollo moon return materials, and they have not been processed by that impact that ejects them off of the surface. And so a lot of people will say, well, my rock that I found in the garden has all these bubbles in it and all these expanding gas vesicles, and so do the ones we brought back from the moon. Therefore, it's a meteorite. But not true. All of our lunar meteorites are a result of a very hard impact that has ejected material off the surface and compresses it.
Certainly. So that's all I had for slides. Just as an interesting side note, we have 0 lunar falls. We got really excited thinking Tiglet might be the first, but it ended up being an Albright with a very lunar-esque look to it. And also, they are all hot desert or cold desert Antarctic finds. There are no European, North American, South American lunars.
Wow. I cannot wait until the first one's discovered in my backyard.
Yeah, not yet.
That's a fun little fact.
Well, as always, Mike, thank you so much for taking us through the science of meteorites through Meteorite 101, the Lunar edition. I'm literally going to be, while I edit that, I'm going to be playing it back and forth, and I'll be able to digest a little bit more through the third time I watch it. But it's great information, so thank you for sharing it every single week, man. Really appreciate it.
Yeah, no worries.
Yeah, love to see the science, Mike. One really quick thing to summarize some of your stuff. So there's the lunar highlands, which is the white anorthosite material that we can see when we look at the moon. There's the black mare basalt, where something punched a hole through, and the basalt lava came up through, crystallizing basalt. And then a lot of the surface is just pulverized. When you think of Armstrong setting foot on the moon the first time, his boots sunk in a little ways. And that is the surface that is constantly pulverized because, as Mike said, all of these things that hit the moon hit with orbital sort of velocity.
Thank you so much. We're going to continue with show and tell with Marissa now. So, all right, hey, Marissa, whoa, what are we looking at here?
Well, we are looking at a nice full slice of the Starry Night Lunar, NWA 13951.
Wow. Gorgeous. Absolutely.
Very nice. Wow.
Yeah, every collector, you know, your goal is to, I apologize for my bird. Every goal is to level up and get bigger and bigger meteorites, and I was finally able to do that this year with the meteorite prices for the lunar meteorites having gone down a little bit.
That is absolutely gorgeous. And I do want to give a little shout out to the nickname or the of meteorites, because I'm a big fan of naming your meteorite, and this is nicknamed the Starry Night Lunar. And Mark mentioned in his video earlier that why he gave it that name, because it really has a little flecks of metal, and it looks like a starry night. So that is gorgeous. It looks like it may even have some crust around the bottom, or maybe that's just hardened caliche.
You know, it might. I'm not quite sure.
I wouldn't be surprised. I think next time you take a look at that in your microscope, I would focus on that bottom lip a little bit there.
Oh yeah, I'm going to. It's all pretty much just on the bottom.
Wow, man. Well, I'm glad you showed that one off to us. But I think actually yours is a little bit prettier than mine. So good for you. We talked about the Starry Night Lunar. Who else can name a nickname Lunar? We already mentioned one tonight.
Stained glass Lunar.
Stained glass Lunar. It's Tuat 005.
Night Sky Lunar.
Well, the night sky is actually Starry Night. Some people started calling it a different name, but it's Starry Night.
Okay.
There's the Golden Lunar.
The legendary one is the one we talked about tonight.
Yeah. NWA 5000.
Yep.
Yeah. So there's a few nicknamed meteorites. And I just think it's interesting and adds a little bit of, we're so limited what we can do by science and the way we can market or advertise or things. So it's nice to have a little bit of a hook, a little marketing hook, if you will, to have a little nickname with your lunar.
But what nickname would you come up for Lambda 20?
The mud lunar. Yeah. I'll show you. I want to show two meteorites, and the reason I want to show these lunar samples is because one shows water alteration and the next one shows heat alteration, and then I'll show one with no alteration. This one was mentioned earlier today. This is Tisserlitine 001. Damian showed this in his video, but I wanted to show this off just because it does show that aqueous alteration, the change by water in there. And I want to show that compared to this sample here. This is NWA 13788, and it is a 1 of 9 lunar melt breccia. Here's the outside of it.
Okay.
I know who prepped that one because of the beautiful cutting and polishing.
Yep. this is just a remarkable piece. And can you see all that metal? Like what you think is metal is metal.
Wow.
It's beyond ridiculously. Those are all metal blebs.
That's
Wow.
a lot of metal.
Awful lot for lunar.
Yeah, quite a bit.
Do you have mice? Looks like
What's interesting about this piece is those holes are actually just the indentation in the external part of the stone that were cut through to make the end cut. But this is a very rare, it's one of 9 only melt breccias.
It looks like there's a green grain in there too, towards the right at about 3 or 4 o'clock.
No, that's probably my finger. Oh no, I see.
No, it looks. Yeah, that sure coming across the video is green.
Wow.
It's left and lighter on the right.
Well, this one is another one of those slices that you can kind of get lost in under your microscope. So those 2 examples show a water altered one and a heat and impact altered one. This one does not show those features, but it does just show the outside of a lunar sample.
Oh, that's
lunar
beautiful.
meteor.
That's really beautiful.
Thank you. This is an unclassified felspathic breccia is what I would call it. When I first got it, it was this entire face was just covered in caliche. And I had to very, very carefully pick at it with a dental pick, remove what I could without removing any of the soft materials.
Did you put it in the ultrasonic too?
I put this in the ultrasonic, but you can't use, I did not use vinegar with my lunar sample. I used vinegar with chondrites, but not with lunar or Mars. I was explaining that my new favorite meteorite, lunar ones, are fragmental breccias. So this is one of 17 fragmental breccias. It was just classified too. And it is complex and gorgeous.
Oh boy.
Is that the one that Daniel just classified?
I really don't know. It's NWA 14685.
So are those melt veins or shock veins with all that breccia?
It really doesn't have a whole lot of melt in there, to be honest with you, that I'm seeing. Like, well, at least, you know how I use the phrase rivers of melt? I don't see any rivers. I don't see any melt patches. Like, if you look at this one compared to, well, I don't have another one handy right now, but this doesn't really show a whole lot of melting at all.
Carl Agee is who classified this one.
Oh,
Carl
thank you.
And a nice big one too, 8 kilos.
Yeah.
Oh my goodness.
Look at that.
Yeah, I was trying to see if it had any crusts or on it, but no, but even on the ends, I don't see any. I don't really see a whole lot of melt, but this is a beautiful one. It may not have all the other colors of the we showed a fragmental breccia earlier that had a bunch of different colors in it. This one doesn't have that, but it's still just absolute gorgeous lunar.
So that's up for sale now?
Yeah, this one and the last one, actually. I thought those were interesting samples to show off. This is one of my favorite ones right here. I have Mike Kelly with a little bit of show and tell, and he's got some rare stuff for us as usual.
Certainly. How's everybody doing tonight? So I wanted to show off a couple of troctolites and one basalt. So let's see if I can get a good focus here. This is the first troctolite, and this is NWA 8687. And what's neat about this one is this is back when troctolite was insanely expensive. So I mean, this is like a 0.68. And I didn't pay the original sticker price for it. It came out of an old collection, but it sold for $600.
Wow.
Ooh.
Wow.
Yeah, back in the day.
Yeah.
Back in the day, Lunars were $1,000 a gram for a long time.
1,200.
Yeah.
And it's a small piece, but it's nice because you can see it's got tiny little bits of the shock veining going through it from, like I said, when it was impacted and thrown. And there are only 41 troctolites out there in the Met Bowl. This was the second one. And this is NWA 10140. And what I like about this one is this one was actually classified in part by a professor at Rutgers, so right down the road from where I live.
Oh, cool.
And it's hard to, I won't be able to show it on video, but at the very corner of the shock melt going through there, it does have the tiniest little green glassy vitreous crystal in that shock melt vein.
Yeah.
So.
Very cool. That looks whiter than the last one. Can you put the NWA 8687 next to it?
And what I liked about this, I don't know if it comes through. Like I did mention, the troctolite is a combination of olivine and anorthosite. So yes, in the 86, 87, you could definitely see more of the green hues that you'd be getting from the olivine component.
That's super interesting, man.
Yeah.
It's noticeable.
Yep. And then the final one I wanted to show off was NWA 032. This is a lunar basalt. Again, this is an olivine pyroxene-based basalt, and this was the first non-brecciated mare basalt out of NWA.
Wow.
So this came with Al Langerich provenance, and he was listed on the classification. And what's neat about this basalt is it's different from the sample returns from either the United States or Russia. So the Luna samples or the Apollo samples. This doesn't match either of those two. And they did dating on it, and this is basically the youngest basalt that we have from the moon.
Wow.
Yep, and it does have a couple pairings out there now, but 032 was the original.
Yeah, and a very, very early NWA. Wow. Dang. Well, that's awesome, man. Thank you so much, as always, for sharing some very interesting.
I had one more that's not mine, so you know me as the micro guy, right?
Oh, absolutely. Hold on, guys. We're gonna go right back to some. Oh my gosh, get ready.
So here's a very non-micro, and thus it is not part of my collection. I have permission to show this off. This is one of the jobs that I'll be cutting. This belongs to Yang. So shout out to Yang.
Wow, love you, buddy.
A very large chunk of lunar. But before, we were discussing the crust color of lunar, and that, a lot of, since they are all hot desert finds or cold desert finds, the cold deserts keep the crust a lot of times. The hot deserts usually don't because of sand abrasion. Well, not this puppy.
Oh, man. That is ridiculously beautiful, dude.
Fabulous crust.
And this is like hen's teeth, people. Lunar crust is rare.
Very. Wow.
So big.
How do you cut that, Mike?
Yeah.
I cut it how Yang tells me to. I think the game plan with this, and I'll be discussing with him more, is to get 2 end pieces and a slice. This way, everything has crust on it, and it's shared and distributed, and all of them are nice looking. Because, the backside is uncharacteristic, or indistinct as far as what sets it off. But I still got to finalize a cut plan with him for what he wants me to do with it.
Can't wait to see the inside.
He has exceptional taste in meteorites.
You can actually see the inside of the part closest to your thumb right there. That is
right. Yeah, there's huge anorthosite class in there.
Yeah, massive. That is gorgeous material. What is the weight of that?
This is 249 grams.
Whoa. A quarter kilo of the moon with fusion crust on it. Wow. You got a bunch of guys about to turn blue down here. Wow. I'm glad Bruce got that one. All right. Hey, thank you so much for sharing that. I really appreciate it, my man. That's beautiful. And Yang, congratulations. Well, that was amazing, guys. What a way to finish the Lunar show with a 1/4 kilo of lunar with fusion crust. Thanks, everyone, for joining us. Catch us again in 2 weeks on YouTube. Good night.
Yeah.
Bye.
Bye, guys.
Good night.
Bye.